Hello there, random smart person on the internet. If you own a small telescope, you can see some really amazing objects in the night sky. Jupiter and Saturn, along with some of their moons, are really easy to see. You can zoom into the craters on the moon. With a solar telescope, you can see sunspots on our own star. But with a small telescope, globular clusters are some of the coolest objects to look at in the night sky.
What is a globular cluster?
I'm glad you asked. A globular cluster is a conglomeration of stars in the shape of a sphere. Globular clusters are bound together by gravity with a higher concentration of stars towards their centers. They can contain anywhere from tens of thousands to many millions of member stars. If Earth orbited a star in a globular cluster, it would be nearly as bright at night as during the day. If you live in the northern hemisphere, the Hercules globular cluster, M13, is one of the best globular clusters to look at with a telescope. This globular cluster contains several 100,000 stars in the constellation Hercules and is estimated to be 11.66 billion years old. This may seem really old, and it is, but it is not the oldest globular cluster ever recorded. A team of Canadian astronomers have used the James Webb Space Telescope to identify the most distant globular clusters ever discovered that may be relics containing the first and oldest stars in the universe. Lamia Mola, co-lead author of the study, said, JWST was built to find the first stars and the first galaxies, and to help us understand the origins and complexity of the universe, such as the chemical elements and the building blocks of life. This discovery in Webb's first deep field image is already providing a detailed look at the earliest phase of star formation, confirming the incredible power of JWST. In Webb's first deep field image, the researchers focused on the Sparkler galaxy, a galaxy 9 billion light years away.
How far away is that?
Far. Really, really far. A light year is a distance light can travel in 1 year. 9,461,000,000,000 kilometers, or 5,879,000,000,000 miles if we're using freedom units. 2 light years is nearly 19 trillion kilometers, and so on. If an object is 2 light years away, it will take light 2 years to traverse nearly 19 trillion kilometers. The nearest star to Earth, Proxima Centauri, is 4.2 light years away. That means it took light 4.2 years to travel to nearly 40 trillion kilometers. We are seeing that star as it was 4.2 years in the past. This image of the Sparkler galaxy is how it looked 9 billion years ago. From their initial analysis of 12 of these compact objects, the researchers determined that 5 of them are not only globular clusters, but among the oldest ones known. This was not possible with Hubble telescope imaging. Since astronomers can observe the objects across a whole range of wavelengths, they could model them and better understand their physical properties, such as how old they are and how many stars they contain. The Milky Way galaxy is known to have about 150 globular clusters. Astronomers know that globular clusters can be extremely old, but it is incredibly challenging to measure their ages. Using very distant globular clusters to age date the first stars in distant galaxies has not been done before and is only possible with JWST. These newly identified clusters were formed close to the first time it was even possible to form stars. Since the Sparkler galaxy is much further away than our own Milky Way, it is easier to determine the ages of its globular clusters. When the JWST observed it, we are observing these objects as they were 9 billion years ago, when the universe was only 4.5 billion years old. Until now, astronomers could not see the surrounding compact objects of the Sparkler galaxy with the Hubble Space Telescope. This changed with JWST's increased resolution and sensitivity, unveiling the tiny dots surrounding the galaxy for the first time in Webb's first deep field image. The Sparkler galaxy is special because it is magnified by a factor of 100 due to an effect called gravitational lensing, where the SMACS 0723 galaxy cluster in the foreground distorts what is behind it, much like a giant magnifying glass. SMACS 0723? Astronomers, step up your naming game! Moreover, gravitational lensing produces 3 separate images of the Sparkler galaxy, allowing astronomers to study the galaxy in greater detail. The researchers combined the new data from JWST's near-infrared camera with Hubble Space Telescope's archival data. The near-infrared camera detects faint objects using longer and redder wavelengths to observe past what is visible to the human eye and even the Hubble Space Telescope. Both magnifications, due to the lensing by the galaxy cluster and the high resolution of JWST, are what makes observing compact objects possible. Instruments on the JWST provided independent confirmation that the objects are old globular clusters because the researchers did not observe oxygen emission lines with measurable spectra given off by young clusters that are actively forming stars. Future studies will also model the galaxy cluster to understand the lensing effects and execute more robust analysis to explain the star's formation histories. So there you have it. You learned what globular clusters are and how the JWST was able to image one of the oldest globular clusters ever observed. Leave a comment down below on what topic you would like me to cover next, and I may make it in a future video. Comments are good for the YouTube algorithm. Whatever video you watch, always remember, have fun with STEM.